Here we have car X and car Y. The rate of car X is R of X and the rate of car Y is R of Y. Now, they start moving at the same time and they are separated d miles. They will meet somewhere after they start moving. We don't know where, maybe here. Let's suppose they meet here after they start moving. The time for each car is the same because they start moving at the same time. This is the distance traveled by car X and this is the distance traveled by car Y. Here we get that the distance traveled by car X plus the distance traveled by car Y is d, the total distance. Now, remember that the distance is rate times time. Therefore, the distance traveled by car X is the rate of X times the time, here plus the rate of Y times the time. Finally, solving for the time it takes them to meet after they start moving is the distance divided by the sum of the rates. For the example shown below, this is the same case because here they start moving from the same point, but they travel in opposite directions. Something like this. Since they start moving at the same time, the time for each of them is the same. And this is the distance traveled by car Y and this is the distance traveled by car X. D is the total distance they travel. And you can apply the same formula. The distance traveled by car A plus the distance traveled by car Y is the total distance. Remember the distance is rate times time. Again, the rate of X times the time plus the rate of Y times the time is the total distance they traveled. Solving for T, the time is the distance divided by the sum of the rates of the cars. Now, solve this problem on your own. If a car A travels at 20 miles per hour and car B travels at 10 miles per hour and they start moving at the same time from opposite ends of a course of 60 miles, in how many hours will they meet? So, you have car A traveling at 20 miles per hour, you have car B traveling at 10 miles per hour, they are separated 60 miles and they start moving at the same time. According to the formula, they will meet after the distance divided by the sum of the rates, 30 miles per hour. They will meet after 2 hours. So here we have car Y and this one is car X. Let's assume that the rate of car Y is greater than the rate of car X. Now, they start moving at the same time and they start moving from the same point. They are in the same position. Since car Y is faster than car X, after a couple of minutes or hours or seconds, car Y is going to be here and car X is going to be here. This is the distance car Y is going to travel and this is the distance car X is going to travel. Now, since they start moving at the same time, the time for each of them is the same. This is t, and the time for car Y is also t. Remember that the distance is the rate times the time. So here we get the following. The distance traveled by car Y minus the distance traveled by car X is d. This is the distance they are separated after a couple of minutes or seconds or hours. Now, the distance traveled by Y is the rate of Y times the time, and the distance traveled by car X is the rate of X times the time. Solving for the time it takes them to be separated, this distance is d divided by the difference of the rates of the cars. Same way here for this example. Again, let's assume car Y is faster than car X. They start moving at the same time. But remember that car Y is d miles behind car X. It can be the miles or the meters or the kilometers. It depends on the problem. But this is the distance. Distance they are separated before they start moving. And since car Y is faster than car X, after a couple of minutes or hours or seconds, they will be in the same position, car Y and car X, because car Y is faster than car X. So this is the distance car Y is going to travel, and this is the distance car X is going to travel. Since they started moving at the same time, the time for each car is the same. And you can also use this formula for this example. It is the same. The distance traveled by car Y minus the distance traveled by car X is d. You can replace the distance traveled by car Y by the rate of Y times the time. Same way for the distance traveled by car X. The rate of X times the time is equal to d. Solving for the time it takes them to be in the same position here is d divided by the difference of the rates. So now try to solve this problem on your own. If a car A travels at 10 miles per hour and car B travels at 10 miles per hour, and they start moving at the same time and they are alongside, in how many hours will they be 30 miles apart? So, since the cars, car A and car B are alongside, so they are in the same position and they start moving at the same time. Remember that car A goes at 20 miles per hour and car B goes at 10 miles per hour. It will take them, according to the formula, 30 divided by the difference of the rates, 10. It will take them 3 hours to be 30 miles apart.